All right. Well, thank you for coming to this second session on education, labor market experiences, and income. My name is Tom Van Huvelen. I'm an associate professor here in the sociology department in Minnesota. We have a great panel today. We are going to be hearing from Dustin Frye, from Ciprian Domnisoru, from Janet Wang, and then from Britton Davis and Alex Jenks. We'll just go through the order of the program. Everyone will have 13 minutes to present. I'll have some nice laminated flashcards to let you know how much time you have left in your presentations. And we'll have questions for everybody at the end of all four presentations. All right. So I think we can start out with Dustin Frye.
All right. Thank you, and thank you to the organizers and those early applause, which we'll see. You haven't seen the talk yet, so that you kind of got ahead of yourselves. My name is Dustin Frye. I'm at the University of Wisconsin in the Applied Econ department, and this is a new project with my co-author Gisella Kagy, where we are. The title brings up kind of this broad topic of urban environmental toxins, but more specifically in this project, and what we hope to have be, a bit of a research agenda. We're really thinking about lead exposure. In particular, we're gonna think about kind of lead exposure through drinking water, and we know kind of from the medical literature and really a broad set, within the medical literature and economics and sociology and public health and many other strands. We know that lead is really harmful, and it's really harmful at kind of any levels of exposure. And I think historically, and in the setting that we're going to be interested in, we're going to look at kind of this historical levels of exposure that were kind of much higher even than the contemporary standards. And so, just to try to jump right into kind of our setting and our context, we are going to look at individuals exposed through childhood, individuals that grow up in towns with lead water infrastructure, the young people, and really we're going to focus on young men in this paper. These are young men that we're going to observe kind of in the early stages of their life in 1900, 1910, and 1920. And then ultimately, we're going to link them forward into the 1940 census, where we can start to see wage and salary income, and we can start to see a host of kind of other labor market related outcomes. And then I think kind of the frontier for the paper and the direction that we're pushing is to try to understand sort of the mechanisms, the channels, particularly thinking about education, which is one that we see really strong in the contemporary literature, and trying to understand kind of a host of different things, and how there were sort of differences in policy and differences in mitigation practices, and whether those played a role in what we find. And so to just set the table as far as kind of our setting and moving back into really the mid-19th century, when we can see we have this sort of figure illustrating the construction of systems in the US. In particular, here we're going to focus on the service pipelines that run from the mains into the homes, and largely kind of as cities are building out their water system infrastructure, they're making this choice between what is typically kind of an iron or galvanized iron pipe or lead pipe. And we're going to, for simplicity in this paper, just kind of classify, like, was the pipe material, did it contain any lead or sort of not, which largely would put you in the iron service pipe systems. And of course, the issue here that we know now, and it was unknown at the time, and was becomes starts being debated maybe towards the end of our period, is how harmful lead actually is in these water systems. Okay, what was not as well established is that lead would actually leach through the pipes at these sort of harmful levels, that would cause kind of a host of issues. And there is a literature that we are, I think, adding on to. I know some people in this room, I think I saw Joe is in here and has really contributed a lot to this. Hamid is in here and has some work that kind of uses and builds off of this as well. And really, we're going to exploit the sort of differences in pipe adoption over time, and also lean a little bit into the fact that more corrosive water, right, the underlying chemistry of the water contributes to the amount of lead that leaches from these pipes into households is ultimately consumed. And so we're kind of building a bit on the research design and leading into elements of the research design that others have used before us. And so back to the data, I talked about this a little bit. We'll get a little more in depth. As I mentioned, we're going to focus on young men that are between 0 and 10 in each of these three waves, the 1900, 1910, and 1920. Then we're going to link those individuals into 1940. And so we're really then going to observe individuals in 1940 that are basically between 20 and 50. And so we can think about sort of all of these different cohorts. For the linking, we're going to rely on the crosswalks from the Census Tree Project. And again, for now, we're just focusing on men because we're thinking about the labor market experience. And when we started this project, I think the Census Tree links really, even then, were sort of more well-developed to follow men. I think as they've expanded and as they've built this out, I think we have sort of follow-up questions to think about experiences more broadly for men and women. We're going to add to this a broader set of locations that were released from this Berks group, with a bunch of detailed place information, and we can try to leverage some of that. And we have some ideas of ways to use not just sort of the larger cities that are enumerated or kind of available in the public use files, but it's kind of more granular location information. And all of the labor market data that we're going to look at comes from the 1940 census. We've started to dabble a little with bringing in 1950. And then finally, the water information we actually take from, and this is again kind of borrows from this literature that pulls a lot of this town information. This was collected kind of over successive years. And then I think the last edition of this gets published in this sort of Baker documents or Baker books, really. There's one from the late 1890s. We also pull in kind of a bunch of different sources that we try to compile over time. We have chemistry information. We've tied together both kind of the most common version from the USGS in the 1950s. We also have a USGS version from the 1930s as well. Just to give like a slight preview so you can sort of see the type of data that we're working with. So this is from where I live now in Madison in Dane County. We can, and this pulls in a bunch of kind of different information that we use. We know roughly when the system is when the Baker book attributes the system to being built, and you can see highlighted in red. We know that in Madison, they were using lead service pipes. Madison, I think, actually was one of the early towns to do a big pipe replacement project. Water chemistry information comes a bit later. And whoops, that was not the link that we wanted. The town chemistry information comes a bit later. And we can see we're going to focus on two elements of chemistry. We're going to focus on pH, so the acidity of the water, and the hardness as well. Once we have kind of this full sample put together, from these two kind of sources, we actually end up with about 4,000 towns and places from the Baker book, and about 1,000 of those then we can find chemistry information for. And so we're thinking about different strategies and ideas that will allow us to maybe expand on that sort of full set of like 4,000 locations, which gets us, just a lot more margins to kind of try to understand this issue. Okay. Like I said, our final sample, about 5.4 million men. Okay. These places, largely all over the country, we can see lead adoption. is everywhere, right? There's, 1,000 dots here, so it's a little hard to see in a super granular way. We can see, we have some figures to try to illustrate some of the distribution of chemistry. What we're going to focus on with chemistry is sort of our measure is going to be corrosive water, which has a pH below 7.3 and a level of water hardness, which is below 100. And so it's really in that towns in that bottom left corner are going to be those that we are classifying as corrosive. Okay. And our empirical strategy in some ways is pretty straightforward. We're really going to kind of leverage these different margins, focusing on facts from an identification standpoint, that this water chemistry seems to be exogenous to the city's level or the city's decision to install pipes, lead pipes or non-lead pipes. And, kind of from this, we'd have expectations that cities that used and adopted lead water systems would have kind of worse long-run average outcomes, and that with more corrosive water, we'd expect those problems to, compound. We have, there's links with full estimating equations. Figured for 13 minutes, we could save those in case you need to see them at that Q&A at the end. They're there, but basically we have a set of town level controls, region fixed effects, a bunch of individual fixed effects to try to account for, some of the selection differences that we see. Just to give a quick summary of the results that we find, wage and salary income seems to have decreased by about 2%. On average, we see higher rates of unemployment, and some of the things that we start to find is we can look at these different cohorts to try to understand some of the kind of cohort dynamics that happen with these groups. Largely, these kind of wage and salary decreases, some of the effects that we find seem concentrated. They start to really kick in people in their late 20s and into their 30s. We don't see these effects maybe as sharply for these younger cohorts. We're trying to understand some of those dynamics. We also start to explore occupation. And so if you look at kind of, we find individuals that were, exposed to more corrosive lead water, sort into kind of lower average paying occupations. We also find even within occupation, those individuals are earning lower wages. So kind of, among laborers, they're paid less than their other laborers. Okay. And finally, just to wrap up, because I know I'm out of time, I mean, what we know is that these sort of these issues are really still very prominent today. We know that there's, large commitments for kind of lead replacement programs and to kind of target and find some of these where these lead service lines are kind of buried and where they still exist. And I think ultimately, like the frontier for the paper, I think we're trying to understand this intersection of education, and a lot of changes are happening in the education environment in this period, including a little more stronger enforcement of compulsory schooling laws. We also have the ability to look at spatial mobility. And then there are cities at some point in here, we're not totally sure when, but they do begin using limestone to mitigate some of the corrosiveness of water. And so we know limestone adoption information, but we don't exactly know the timing. So we're working to understand a little more how limestone matters. So I think I'm out of time, but thank you. Okay, yeah, thank you.
And just try to stay by the mic so the online folks.
Okay, I'll try to stay by the mic. Okay, hi everyone, I'm Ciprian Domnisoru. I'm an assistant professor at Aalto University in Helsinki, Finland. And this is work that I started as a postdoc at the Berkeley RDC. I would also like to thank the organizers of this conference and the pre-conference workshop, where I learned a lot about linking data sources. So I'm going to start with a disclaimer. So none of the institutions that funded or provided the data necessarily share our views. And we're looking at female teachers, okay, and the impact of female teachers on girls' lifetime achievement. okay? And we reviewed papers in the economics literature, and it turns out that the results are mixed. So there's plenty of evidence that female teachers do impact female students positively, but that happens when there's very few professional role models in that country or in that specific field. And this is exactly the context that we're studying. We're studying the rural United States in 1940, and this was a time when very few women had positions of influence in society. So just to give you a preview of our results, we find that being exposed to more female teachers led to a higher chance of continuing your education and then having higher lifetime income, okay? And actually some effects on longevity. So we're using linked census files. So our main source is the 1940 US Census 100% file, which we linked through the Census Bureau's CLIP project to the 2000 and 2010 census files, and then the Numident files. And we're going to be looking at 7 to 14-year-olds in 1940. These are children, most of whom are still living with their parents. So we get a lot of information about the household as well as their parents. And then we also have a sample of teenagers. They're going to be 15 to 18. And all these kids are living in rural areas. We also have a sample of Black teenagers, but in the interest of time today, I'm only going to show you results for white kids, because for Black teenagers, the match rates to future census files are much lower, and that kind of deserves a separate discussion. So here's a typical regression in this literature. You look at some kind of outcome, typically an education outcome, YIJ, and then you ask, what is the effect of being a daughter? That's D over there. What is the effect of having a female teacher or fraction female teachers? And then there's an interaction term, okay? And then the effect of, for a female student being taught by all female teachers, and this specification would be alpha 2 plus alpha 3, okay? And there's some really interesting evidence. For this to be causal, right, you would need an experimental situation. And there's some situations where teachers are randomly assigned and then maybe students are randomly assigned. So one example is from the US Air Force Academy. There's a paper by Carell, Scott, and West. And they find that female students who were assigned to more female teachers had higher progression in STEM subjects at the Air Force Academy, okay? But typically, you're not going to find an experimental situation, so you will start to worry. One thing is that you might worry that parents sort into schools based on the kind of gender that they want for their children. You might worry that teachers sort into places. And then you might worry about the assignment of who's actually was your teacher, okay? So we worried about all these things, and I'm sure you can find more things to worry, but I'll save that for the discussion. So the first thing we are not so worried about is sorting of parents, because these were rural schools and fairly difficult to get to. These were one-room schools, so we think that sorting of parents in these rural areas was fairly limited. We have some empirical evidence on that. The other thing is, what's our unit of analysis? And we're using, for the most part, the enumeration district. So I'm sure many of you know a lot more than me about enumeration districts, but this was an area, maybe a neighborhood, but large enough for a census enumerator to actually walk around and collect the information. So that's going to be your unit of analysis. And then we're going to be measuring the fraction of female teachers, which we observe in the full 100% sample within that enumeration district, okay? We've also tried, given the structure of the data in the 1940 census, to look at who's your closest teacher, or who are your closest 3 or 4 teachers, and so on, and results are very similar. So essentially, our research strategy is to compare these enumeration districts with high or low fraction female teachers, and we're going to have a county model where the variation is going to be coming from variation between enumeration districts within the county, and then we're going to be comparing boys and girls within an enumeration district. There we lose the main effect, so we're only going to be looking at the interaction effect for daughters, for girls. And we also have a household model where we compare sisters to their brothers. So as I said, you might be worried about a few things. One is that families strategically sort into these enumeration districts based on the gender. We don't think that's a big problem. The other thing you might be worried about is that the distribution of female teachers within the enumeration district might not be as good as random, okay? So there might be reasons why some places might prefer to have female teachers, one of them being patriarchy, for example, or, right? So one thing we did was we looked at the actual distribution of male and female teachers in these places. And the solid lines are the actual data, and then the dotted lines are the prediction from a binomial, right? So depending on how many teachers were actually in the enumeration districts, we actually plot predicted versus actual, and they're remarkably similar. And we think that this reflects that, yes, there might have been county-specific reasons why some places had more or fewer female teachers, but then within these enumeration districts, it was fairly random, okay? But if you're not convinced about that, we also did some analysis where we're comparing across all the enumeration districts. We looked at what fraction of women who were not teachers were actually in the labor market. That's going to be correlated with these patriarchal views about what women should be doing and what daughters, how much education they should be getting. And then our results across these, quintiles are very similar. So we don't think that's a huge concern. So this is our main model. We have the regression specification that you saw before, but then a lot of extra controls because this is 1940 census. We know a lot about the parents, the household, the neighborhood, right? We know exactly where these people lived, as well as the county, okay? So we throw in everything, right, but the kitchen sink. And then we actually do have a percentage of households with a bathtub, right, in the county. So there's a lot of very granular neighborhood and county characteristics, all of which are interacted with gender, okay? So as I said, we also have the enumeration district model and the household model where we're only going to show you the effect of the interaction term, okay? Because the main effect is absorbed. And then the other thing that you might be worrying about is how we're able to determine, right, who was your teacher, right? So there's going to be measurement error in what is the fraction of teachers that these kids were actually exposed to, okay? And we have a measurement error model that predicts that the main effect is going to be biased towards 0 and that the interaction term is going to be attenuated, okay? And we have a way of dealing with that measurement error. So these are our headline results, and I'm just going to show you the being on track to attain 9th grade, okay? So about 75% of these girls did go to 9th grade. And then the effect of having all female teachers on daughters is to increase that baseline by about 3 percentage points, okay? The kind of meaningful variation you could expect in fraction female teachers is about, 50 to 60%. So you have to scale that magnitude, of course. And then the main effect seems to be negative. Reassuringly, the enumeration district model and the household model are very similar in magnitude. And then when we look at less educated parents, where you think that teachers might matter more because the parents themselves don't have education, a lot of education, the magnitudes are actually higher, okay? So this is what happens when you gradually add covariates to this model. So as I said, we really try to exploit the data structure in the 1940 census and gradually add neighborhood controls and teacher controls and county controls. And the interaction effect is remarkably stable, okay? Which we see as very reassuring for our causal interpretation. Here's what we do about measurement error. It turns out that the state of Wisconsin had a book where they collected all the teachers. They had the names of all the teachers and the schools. So we can actually collect the data and link it to enumeration districts in 1940. So we have a measurement from administrative data of what fraction teachers were female in the state of Wisconsin. Other states did not have this detailed information. And what we do is we use that as an instrumental variable to kind of correct for measurement error. And once we do that, the magnitudes increase quite a bit because remember, we think that this interaction term was downward biased because of measurement error, okay? So we think that the effects are quite a bit larger in terms of 9th grade completion. So turning to 2000 outcomes and later outcomes, so these kids were 7 to 14 in 1940. Now we're switching to 2000 when they would have been 67 to 74. And we look at those who survived, obviously, and then we look at reported years of schooling, high school completion, Social Security income. We look at longevity and also whether they survived to the 2000 and 2010 census. And then reassuringly, there's evidence of impact on completed years of schooling. So having more female teachers for daughters has a positive effect on overall education, high school completion and some college from a lower baseline. And then also consistent with these results on education, higher effects on income, and also consistent with the education effects, an increase in longevity. Okay. So just to conclude, we think that our evidence is consistent with this role model hypothesis for why having a teacher of the same sex would matter in terms of your attainment. And we think that our evidence contributes to this literature by pointing out these lifetime effects of early childhood exposure, right, to teacher gender, which has been relatively understudied in the economics of education literature, precisely because these linkages between the 1940 and 2000 and 2010 census files only became available recently. Yeah, thanks.
Hello, I'm Janet Wang. I'm a PhD student at the University of Michigan's Sociology Department, and I'm here today to present findings from a paper titled Education and Later Life Income Dynamics of U.S. Men and Women. So the economic benefits of education have been well documented by scholars across multiple disciplines. We know that workers with higher levels of education receive not only higher starting wages, but also experience faster wage growth. However, we know less about the economic benefits that carry over in later life. But learning about these is important for understanding life course processes of stratification. And the existing research on early to mid-career workers can't really help us shed light on what we'd expect to find for adults in later life, because we know that older workers and people who are no longer working undergo different experiences. Hopefully, these results can update our understanding of educational returns across the entire life course for men and women. So I asked the following questions in this paper. First, I ask, do income differences by education increase, decrease, or remain relatively constant for US men and women after age 50? And secondly, I ask what specific income components, such as Social Security, pension, earnings, capital, and transfer income, become more or less stratified by education as people age. So I asked the second question in an attempt to understand the answer to the first question, which is about total individual income. I use a life course framework to guide this paper, and the theories I've listed below can help us understand what I might expect to find empirically in this paper. First off, cumulative advantage theory suggests that income differences by education would increase with age. And specifically, I draw on the Blau and Duncan form of cumulative advantage theory, which states that group differences tend to increase with age. Secondly, status maintenance theory instead suggests that income differences by education stay the same with age, and that they are carried forward but may not necessarily magnify. And finally, status leveling theory posits that income differences by education decrease with age. And there is some empirical evidence that would suggest that this could happen to later life income or later life income components. However, the exact nature of the relationship is unclear. However, we do know other things about income in later life. We know that income sources change across the later life course. People who are working formally collect earnings income. People who are retired may collect pension income and or Social Security income. And then capital income and transfer income is collected across ages 50 to 80 as well. Existing research on income and wage differences by education tends to focus on early to mid-career workers. And we see that these differences do increase with age. However, this relationship is slightly different for men and women. Furthermore, we know that gendered career pathways and then differential rates in educational attainment and labor force participation, especially for older cohorts in the health and retirement study, means results may differ for men and women. And thus, this kind of provides me with analytical considerations, such as running models separately for men and women and considering what additional covariates may influence this relationship. Now, we know that income sources have varied differences by education, and this work is done perhaps cross-sectionally for these components of later life income, or we have results for early to mid-career workers. We know that earnings and capital income tends to be quite stratified by education, but Social Security income is a more equalizing form of income that older adults may receive. But like I said, these existing pieces of information kind of only contribute part of what we know about education and income. And it's especially important to look at the relationship between education and income with age, not simply as a cross section, because we know that stratification is a process rather than a static state. Given the progressive nature of Social Security income and its increasing prominence as a source of later life income, I hypothesized in this paper that I would expect income differences by education to decline with age for men and for women. In order to answer my research questions, I used the Health and Retirement Study. This is a longitudinal, nationally representative survey conducted by the University of Michigan that surveys US older adults every 2 years. And I used the harmonized version of this study that is cleaned by the RAND Corporation. And I'm very thankful for that, because you'd expect a study conducted by the same place to be relatively consistent across waves, but that is certainly not the case. My final analytic sample consists of roughly 36,000 individuals observed at ages 50 to 80 for a total of over 200,000 person years across the years 1992 to 2018. As for my measures of interest, I categorize people's educational attainment into one of 4 categories. People have less than a high school diploma or equivalent. People have a high school diploma or equivalent, like a GED. People have some college education or perhaps a 2-year college degree, and people have at least a 4-year college degree. I also categorize age in this way to reflect transitions out of the labor force. And also, I take the natural log of income when conducting analyses and inflation adjust prior to taking the natural log to 2018 dollars. And this is quite standard in the area where people are looking at the relationship between education and income. I employ random intercepts linear regression to capture longitudinal differences in income by education across age. And so here I have the model, and vectors are bolded. So we see that I have coefficients for age group, education, and then the age group education interaction term. And so this interaction term helps me capture what may happen to education differences as people age. And then I also have a series of covariates that can account for this relationship as well. So I have covariates for race and ethnicity. People are classified as Hispanic of any race, white non-Hispanic, and Black non-Hispanic. There's also birth cohort and recession year to capture certain economic experiences, as well as household employment status, because I recognize that a lot of these people in these surveys are not living by themselves, but rather in a household with another person who may or may not be working, and that may influence their economic behavior. I also have a retrospective employment history variable that captures prior economic engagement with the labor force to kind of account for different rates of labor force participation and occupational stability for men and women. And I also have a marital biography variable, and this matters a lot, particularly for women who are living in a 2-person household. And I also cluster my standard errors by person when conducting these analyses, but I do not use weights in the random intercept linear regression. And these models, I run them for total individual income and then for each individual income component, because those sum up to total individual income. And I'm left with a lot of coefficients, but for the sake of this presentation, I will present some figures instead. So I have here the average marginal effects of education for men on the left and women on the right. So overall, I do find evidence of status leveling. That is, income differences by education do decrease with age for men and for women. But what we see here is that it's happening earlier than you'd expect if I were to say this is solely driven by increased collection of Social Security income, which is a more equalizing form of income as opposed to earnings or capital. And another important thing to note is that the average marginal effects of education, these are all relative to having a high school degree, by the way, that is the base comparison group. They tend to be larger for women, especially especially at ages basically 50 to 67, 69, but the magnitudes are similar in size for men and women by ages 75 to 80. And in part, this is because the education coefficients are also larger for women. They also have a lower total income compared to their male counterparts for each educational category. And this is especially evident when I show you the predicted income trajectories by education. So this kind of shows what exactly is going on when we observe these declines and differences. So I said earlier that income differences by education are decreasing for men and women, but they do so in different ways. So the decline happens earlier for men than for women. We see it happens right away after ages 50 to 54. And a large part of this decline is driven by the rapid decrease in college-educated men's earnings relative to other people. And we see that in the yellow line that denotes those with college educations. On the other hand, women have declines in differences later. So we see that the declines don't start until age 60 and onwards. And rather than this overall downward convergence, we actually see an upward convergence in predicted income from 60 to 69. These declines occur before most of the sample is collecting Social Security income. So it's not just the equalizing nature of Social Security that's driving this. And then as for the component incomes, I have a lot more tables, but in an attempt to summarize, I find what you would expect to find, where earnings differences are quite large at age 50 to 54 and become smaller as people exit the labor force. Differences in capital income are large and remain large. Pension differences, on the other hand, start small because very few people are collecting pension income at ages 50 to 54, but differences by education are quite prominent by ages 75 to 80. And finally, we'd expect to see that Social Security income differences and transfer income differences are small and remain small. Like I said earlier, because of the progressive nature of Social Security income and the fact that a lot of these transfers are government transfers. And these changes contribute to an overall decline in income differences by education. So to conclude, I find that income differences by education decline with age for both men and women, but in different ways. The leveling occurs before traditional retirement ages, 65 to 67 in the United States, and results from the dynamics of multiple income sources. And the upward leveling of women's incomes across 60 and the downward leveling of men's incomes 50 to 59 do not reflect a simple assumption that Social Security income leads to more equal incomes at age 65. And despite the apparent patterns of increasing equality with age, income differences by education are still prominent at ages 75 to 80. And thus, education remains a salient influence on later life outcomes. Also say that results also point to the worrying possibility of rising education-based stratification in non-Social Security income, especially for future cohorts. Since we know that non-Social Security sources of income, such as pension, earnings, and capital, are rising in popularity as younger cohorts enter older adulthood, we'd actually expect income differences by education to increase in the future. And given the diverse marital and employment experiences of men and women, as well as the remaining income stratification at older ages, one-size-fits-all policies may not equally benefit economically vulnerable older adults. And furthermore, I hope these findings provide an update to our understanding, not only empirically, but what we need to consider when conducting sociological research on income and educational returns across the entire life course, not just people of prime working age. And I would just like to thank the Juster Economic Behavior Research Fund for their generous support, as well as the NIA Predoctoral Traineeship Program. And I'm also happy to answer your questions later or via email. And thank you for listening.
Hi, everyone. My name is Alex Jenks. This is Britton Davis. We're both seniors at Brigham Young University as part of the record linking lab headed by Dr. Joe Price. Our research is focused on exploring the relationship between income and lifespan using historical data. This is still a working paper, so we're eager to hear what advice you guys have for us. So our motivation stems from this figure given in a paper by Dr. Schwant of Northwestern in 2022. And in this figure, you can clearly see that there is a positive relationship between income and life expectancy. So we looked at this and we were curious to see how we could extrapolate this to the entire country historically. And so, with that figure and also a paper by Drive and Erickson in 2023, they found that in the early 20th century in Sweden, an increased income was correlated with lower life expectancy. And some of the reasons that were attributed to this relationship were, people with higher incomes could afford to live more flamboyant lifestyles, including, more smoking, drinking, and over-consuming food. So that leads to our research question. What is the historical income lifespan gradient in the United States? So our kind of game plan to tackle this question was to assemble a data set first, and we would need lifespan. So that includes birth year and death year, income, location, and demographic data, urban, rural, gender, etc. And then use that data and run our analysis. Quickly, we ran into an issue. Those of you familiar with the census in 1900 to 1930 understand that income was not a variable in the census until 1940. So as we looked through the census, we found OX score. An OX score is a variable which assigns occupational income scores to each occupation. We used this as a proxy for income and proceeded.
And so with our data, we use the IPUMS full count census data, which includes our census tracts, our birth year, these OX scores, gender, urban, rural, all of these individual characteristics. And then we use the database of human lifespan, which is a proprietary resource that we have at Brigham Young University, where we use the family search identifier, which links people not just across censuses, but across their entire life, and finds death data available through the Numident and any other available resource. And we're able to link the people in the census to this database using the family search identifier. And so this database is unique because it doesn't just include the Numident or one death record, but includes many records from various sources. But it's also been curated and audited by public users and trained genealogists. And so there are plenty of pros and cons with that, with it being publicly available and publicly editable, but it also gives us a lot more access to death records than just one source. And so what we look at is we start with the 528 million full count census observations, and we only use working males from age 20 to 59. And so that brings us to 129 million census surveys. And from that, after we link them, we're able to get 69 million census surveys, which is 27 million working males linked across all of the censuses. Yeah. And so this is our sample, kind of the distribution of the different years. So we start out with a very rural population in 1900 with 72%, and then it moves to 1940 to be almost 50-50 rural urban. The married and not married stays relatively the same, and so do the ages. And as you see, we have a very high proportion of white in compared to the other races. We didn't exclude any of the races, but due to the data, we're oversampling white because they have a higher probability of being linked and having death data available. And so that's definitely one limitation. We'd like to expand our linkages and our death data to include a more even proportion of every race and ethnicity, but that's our data as of now. And so starting with our results, we found that in each census year of 1900 to 1940, the bottom quintile of wealth lived longer than the top quintile. So in 1900, that was a difference of 72.8 years to 70.4 years, which is a negative linear gradient of negative 0.049. And then in 1940, we saw that the gap decreased over time to a difference of 73.6 to 73.1 years. And so that's our relationship, and this is it graphically. So we have each of the census years, this relationship, our cubic polynomial graphed. And so as you can see, the difference in 1900 is quite dramatic, going down to a smaller gap in 1940, where it's still slightly negative. And so in this, we're kind of showing how the relationship changes over time to be more, how we can extrapolate this graph to see the modern graph and how it's flattening over time to then become positive today.
So to further check our results, we ran two different regressions, one where we just included the Ox score percentile, and the other we included all of these different demographic variables, race variables, as well as marriage and immigrant status. And as you can see, and we wanted to see, were these different variables significant and how did they change the coefficient for the percentile of Ox score. And as you can see, the coefficient for percentile remains significant in both cases and fairly similar. Most of the race variables were not significant with the exception of Hispanic, but we did find that the marriage and immigrant status did have significant effects between the two. And so then we also looked at how the top quintile differs from the bottom quintile in both ends of our timeline. So in 1900, we could see that the top quintile was slightly more likely to be married than the bottom quintile. They were much more likely to be urban, slightly more likely to be white, Asian, Hispanic, and less likely to be in a small household and less likely to be Black. Now, when you compare that to 1940, the top quintile is much more likely to be married. Urbanization rate is the same. They're more likely than in 1900 to be white. And then, as you can see, Black, Asian, Hispanic are all negative factors in 1940. And so because it's not perfectly consistent between the 2 years, these differences could be confounding variables.
And so now we split up our results and reran it, just including urban and just doing it by rural. And we saw that in the urban regions, we do have a slightly positive trend. And so if you're in the lower income percentile and you live in the urban city, then the relationship switches and you're less likely to have a higher lifespan per lifespan. And then if you're in the rural, if you are in a higher income percentile and live in a rural region, then you are more likely to have a lower lifespan. And so this could also be one of the things driving our effect. And especially in 1900, the graph, the rural graph is weighted about 75% to the urban one, where in 1940, they go to 50-50. And so these graphs are showcasing the relationship, but we still see even in the rural graph that the relationship is decreasing over time. And in 1940, it is flatter than in the other years, still showcasing that the relationship over time is moving to a positive trend. And then we also graphed this by our two age group extremes. And this is really to showcase that the relationship isn't just driven by the low income of the 20-year-olds who have a higher life expectancy versus the older, higher income groups who might die sooner. And so we see that this relationship is still negative and still flattening in all these years. The only positive relationship we found was in the age 20 to 29 in 1940. There's a slight positive difference from the bottom to the top extreme, but this is still showcasing that the relationship is flattening over time and is still negative in most of the years. And we're seeing the evolution of it. And so to conclusion, this during 1900, 1940, we find that those in higher income percentiles were correlated with shorter lifespans, showing that transition to the Schwant paper and how in the early 1900s we have a negative relationship, which might be driven by some of these lifestyle reasons, as mentioned in Drive and Erickson, that the lifestyles in the Roaring 20s and the Great Depression, many of the higher income percentiles had more access to sedentary lifestyles, to unhealthy products that they consumed, and especially since we had 75% rural, that those lower income individuals in the rural populations were most likely farmers who didn't have access to those things. And so in the future, we think that the temporal and cultural contexts are important to consider when analyzing this relationship, and that further research should investigate other historical data sets, as we mentioned, to try to expand our linkages to include more races, as well as being able to include more death data, so we're able to include more people. And we're working to incorporate the Nuvident more, so that we can expand that death data set to be complete. So yeah, thank you.